Hi, is everyone having a good time? Yeah? Yeah, awesome. So I'm going to skip this slide because I just got an awesome introduction, which isn't usual, so thank you. I work at a company in Denver called GoSpotCheck, and I also am a mentor. I teach students how to code all around the world through a program called Block in my free time, which is super fun when I'm not fly fishing or outside. But today I'm going to talk about refactoring. So it's a big part of what we do as developers, obviously. So while technically it's not a refactor, performance optimizations are a common thing that we do. We also refactor to implement a design pattern or to make the code better in some way. But what if I told you that there was a refactor that would be more impactful and more meaningful? And I think that's refactoring to make code more readable. And I think that good design means more readable. So obviously I get there are times where readability gets trumped by other things. We are currently dealing with scaling issues at GoSpotCheck, and sometimes we need to do whatever it takes to keep our app up and running. And a lot of times that means writing really ugly, unreadable code. So I think you should save this as a last resort. I think readability should always trump performance unless it's absolutely necessary. And a lot of times those optimizations can cause readability to deteriorate. So this is a graph from Jeff Atwood's blog. I'm sure some of you know him. You can see here that from his perspective, we spend way more time trying to understand code than we do anything else. So I think readability is really important. Also, Nat Price and Steve Freeman say that developers spend far more time reading code than writing it. So that's what we should optimize for. Growing Object-Oriented Software, Guided by Tests is a really great book if you haven't read it. Also, Michael Feathers says that readability is the best default or the most important aspect for nearly all code. So today we're going to talk about teachable versus readable code, go through some quick examples, talk a little bit about components, and then get into the how and why. So first, starting with teachable versus readable. In previous versions of this talk, I approached this issue as almost dumbing down the code, or refactoring code to make it more readable for a junior developer. My mentor and coworker, Kim Barnes, then taught me that what I was referring to was something called teachable code. Teachable code should not be the norm in production code, and I don't want it to be confused with readable code. So I want to be clear that making code more readable does not mean dumbing down the code. So readable code truly means better designed code. So Peter Jang wrote an article that I really loved, and he said that readable code is code that clearly communicates its intention to the reader, whereas teachable code is code that makes the specific concept being taught as explicit as possible. So concepts related to teachable code is important because it can really help juniors in your organization level up. Kim doing this with me helped me level up and grow a lot quicker. But always make sure you work your way back to the production code because you don't want teachable code in production, because I think it does a disservice to your code base and the other developers on your team. So I'm going to really quickly go through two examples of readable versus teachable code. So in this first example, this is an example of readable code or code that you would have in production. So it's a succinct, readable way to find our dogs here. Whereas teachable code, on the other hand, could look something like this, breaking it up into 3 lines and being very, very explicit about how we are finding the dogs here. Another example is taking one big class or method and breaking it down. So here's an example of readable or production code. We have small methods that are named well, and they each have their own responsibility. Whereas teachable code would be combining all these methods into one so it's easier to follow and more procedural-like. So that would be an example of teachable code. So it's important to slow down and take small steps when explaining these concepts using teachable code to juniors. So I wanted to make sure to make that clear that readable code is not teachable code. So now we're going to get into more readability examples. So first off, naming. This is a popular blog on presenters and Rails. It shows us creating this instance variable called post, but as you can see, post is referencing a new instance of post presenter. So why not call this instance variable post-presenter? Then I know that I can only call methods in that presenter class rather than from that post class. I don't have to go back and find where I'm instantiating that variable, and it's clear from the get-go. Also, don't be afraid of long names. I always see people abbreviating things or using one word when if they used 4 words in naming something, it would be that much more clear. A variable's name is a comment, and you should take advantage of that. Also, John, who's around here taking pictures before I got up here, told me that writing good test descriptions is also really important. Describe what you're testing. It makes everyone's lives a lot easier. Also, stick to the standards. I came across this in my code base a couple months ago, and obviously there's no vertical spaces, and it really bothers me. Our team has a standard of using spaces. Our industry has a standard of using spaces, so use them, because I see this as laziness, and it's obviously really hard to read. So the biggest piece of advice that I have for making your code readable is to stop writing clever code. Justin Searles, he gave a great talk a while back at RailsConf, which you should all go watch, but he had some really funny quotes about writing clever code, such as, "Your clever code does not impress me. Your clever code makes me feel stupid." Write fancy code in your side projects. I know it's really fun to experiment, fun to show off something new you learned in a blog post, but save it for your side projects. Don't sacrifice the readability of your code for everyone else on your team because you want to show off. So, as Justin would say, be courageous and write boring code. The goal should not be to minimize lines of code, but rather minimize the time needed to understand it. So now let's talk about some longer-term refactors that you can do to make your code more readable. Chad Fowler says, if your services are so small that you can read them in one go, you probably don't need a test. I'm not sure I agree with the test part because I always write a test before I write code, but I like the idea of reading them in one go and understanding what's happening right away. So break things into the tiniest things possible. That will help make your code more readable and better designed because you're not only following single responsibility, it has one job, but you're also working with smaller objects and you're able to keep the context in your head instead of like, wow, what is this doing? There's too much going on, too much cognitive overhead. Also, name these objects well so it's clear from the get-go what their responsibility is. So I know this is a Ruby conference, but my next example is in JavaScript. The same concept would obviously apply in Ruby, and I wanted to prove a point that JavaScript could be readable too. Well, somewhat readable because we all know that JavaScript kind of sucks, but it is also one of the most recent refactors that I've done that applied these principles because I've been working on a new service where it's already designed really well from the get-go. So recently, I needed to fix a bug in this 300-plus line backbone view that had very few tests. This is only like the top half. I couldn't fit it in a screenshot. That's how long and big this file is. So to even know where to begin or figure out what this view was even doing, it took me a really long time, probably a half a day. It was completely unreadable, unmanageable, and overwhelming. These types of huge views or classes can be very overwhelming, obviously, to any developer coming into it. It took me a while to locate where the bug was, obviously. So my pair and I decided that we were not only going to fix the bug, but we were going to take on refactoring this class to make it more readable and better designed. And on top of that, we decided to test drive everything. So once we started pulling things out into smaller POJOs or plain old JavaScript objects, it became easier to understand what was going on. We thought it was going to be such a pain in the ass to test this stuff. We used Jasmine, a testing framework. But the more we broke things out, the easier the tests became. So we started by creating a filter processor factory that returned a new instance of the type of processor that needed to handle the filtering based on its filter type or subject. After that, we broke each type of filter into its own processor class that processed the filter based on the way that it needed to. And slowly, our 300-line backbone view started to become smaller and smaller, and it became clearer and clearer what it was doing. And lo and behold, it actually started to become more readable. We then realized that we could extract a base class for all the processors because every processor took the same constructors, and we were able to delete a ton of code from the original backbone view. I should have counted, I should have looked at the diff to see how many lines we deleted. But we also deleted a ton of comments because the code was now clear what it was doing and we didn't need them anymore. And obviously, comments should be a smell that your code is not readable. So this refactor, once we figured out what was going on, it only took us a day to do. I thought it was going to take so much longer, but I'm really glad we took the time to refactor and test drive it, rather than just finding that bug, fixing it, and moving on. We ended up with fully test-driven code, a fixed bug, and very readable, extendable code. We also ended up with tiny, flexible pieces of code that we could plug and play that could be reused in our code base later. So examples of refactors like this really reinforce that truly readable code means good design. And this stuff isn't new. I'm sure most of you have heard and seen these things before, but rarely do we get this perspective of someone who's not a senior developer, and also we don't really get into the how and why. So how can we write more readable code? Awareness, raising awareness about this on your team, and always have this in the back of your mind when you're writing code. Pair. I often have discussions with my pair about what is readable, what's not. It's really helpful to have a second pair of eyes on it to call out code that is maybe more clever than it should be. Also, take more breaks. Step away and come back, and oftentimes you see something is unreadable with a fresh perspective. Also, code reviews. Make this a point in code reviews, whether you're doing team code reviews where you put your code up on a screen, which is always really scary, or when you're reviewing pull requests. Always have readability as a tenet. Always follow this rule. Leave the code better than how you found it. Take the time to do these refactors and make a commitment to leave the code in a better place than how you found it. It's so tempting to just fix a bug and move on, but I really think it's worth it to take the time and refactor it. Build code readability and good design as pillars in your engineering organization, and make sure the rest of your team is on board. And most importantly, embrace why it's important. So why is this important, and why does this matter? I switch what work streams I'm working on at my company a lot. We want to try to eliminate the bus factor, so if one of us gets ran over by a bus, we know what's going on, we're not fucked. I feel super unproductive in just trying to get the lay of the land when code is unreadable. And we feel that we can make informed decisions and write more readable code as a result if we're constantly switching contexts. Code is also easier to change and maintain. I don't have to spend time figuring out what the code is doing. I don't have to put in a bunch of put statements everywhere to see what's happening on each line of code. Bug fixing is obviously easier, like we saw in that earlier crazy JavaScript example. I'm able to quickly diagnose the problem, write a failing test, make a change, run my tests, and if the code is understandable and clear, I can be aware of any side effects that might happen later. A lot of readable code is tied to best practices. Look at Sandy Metz's Pooter book. How many people have read that book? Most of you, yeah. And if you open any page in that book and look at a code example, the code is so readable. You know exactly what is going on. And she also breaks things into small, tiny parts that have one responsibility. Also, engineering teams can work remote more easy. It's becoming quite the trend in the industry to be able to sit at home in your pajamas with your dog and instead of having to go to the office and sit in rush hour. So it makes it easier for remote teams to work because you don't have to constantly be in communication like, hey, what is this doing? Can you walk me through this? What's going on here? Onboarding becomes a lot easier. Onboarding is really important. It's a really hard thing to do. Most companies suck at it. But the more readable your code is, the easier it is to onboard new developers into your team. Also, we are humans developing software with humans to benefit humans. Ernie Miller coined the term humane development, and we're doing so much more than just writing code for the machine to understand. We should be focusing on writing code that our fellow teammates can understand and work with easily, and we oftentimes forget this. Also, different backgrounds. It's really amazing that the Ruby community continues to become more and more diverse. More people from different backgrounds are learning to write code by either teaching themselves or attending a boot camp. Diverse people with these different backgrounds, more often than not, have not been coding or building computers their whole lives. So let's write code that supports inclusion by making it as readable as we possibly can. And a lot of people with diverse backgrounds are juniors in the industry, and a lot of times companies hire juniors without any mentorship capacity. But I also think it's important to not only have enough senior developers to support the juniors, but also to have readable code bases that are maintainable. It's important to create a culture that's not toxic and supports learning, but I also think having a readable code base can make a big difference when you want to onboard and grow junior developers on your team. A lot of times I hear, oh, we don't have enough senior developers to maintain a mentorship program or to onboard juniors. But I also think you should be saying, hey, my code base is pretty shitty. I don't think we're ready to really have any juniors come in and work in it. Well-designed code helped me level up quicker at Go Spot Check. But also, doing refactors like I did that you saw earlier helped me grow as a developer. So obviously, there's still a lot of shitty code in our code base, but making examples out of it really helped me out. But writing readable code is even bigger than helping junior developers. Matt's created the Ruby language because shell programming sucked. It wasn't readable, it wasn't fun to work in. Readability is the principle of why Ruby was founded. So let's not forget that. Minneswan stands for Matt's is nice, so we are nice. And I used to interpret this as be nice to one another, don't be a dick. But now I realize it means so much more. It means write nice code. And that is the driving force of the Ruby language, and it's awesome. So if you are in the Ruby community, you should be holding up these values. Programming is a sharing economy. We have all these awesome gems that we get to use for free, and it permeates through everything. So a lot of times I feel like we're losing it. So let's remind ourselves of this every day and make sure everyone learning the language knows how important readability, sharing, and inclusion is in the Ruby community. Embody empathy when programming. We talk a lot about having empathy outside of writing code, so like with your coworkers, etc., not being condescending, that sort of thing. But also, you can write empathetic code by making it more readable. So always be questioning your code, always be pushing yourself to be better, and keep your code readable. And remember that well-designed code is readable code. If you're looking for more examples, you can pick up The Art of Readable Code that was written by two guys at Google. It has some great examples of readability refactors, both on a small and large scale. Obviously, Sandy Metz's book, which most of you have already read anyways, but it's fun to open that book and pick out a piece of code and see how readable it is. So in lieu of the conference theme, let's make the future of Ruby readable. Thank you.